Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone and welcome to the fourth part of the end of term revision for grade 11 advanced mathematics. And in this part we will discuss sequences and series. We will discuss sequences and series. And just to remind you, if you feel confident with the topic itself, you can skip to the second part of the video where we actually explain the questions and solve them. Let me zoom out a little bit so it is much clearer. Okay, there are two main types of sequences. The first part is, or the first type is arithmetic, and the second type is geometric. So arithmetic and geometric sequences. So geometric. And an example of arithmetic sequence is the following. So if we have 3, 6, 9, 12, 15, 18, and so on, so on, so on. And an example of a geometric sequence is, let's start also by 3, and then 6, and then 12, and then 24, and then 48, and then 96, and so on, so on, so on. So what is the main difference? Here, what we do is increase by a positive number, so we add 3 every time. So plus 3, and so on, and so on. And here, what we do is multiply by a certain value. So we multiply by 2, multiply by 2, multiply by 2, and so on, and so on. So here we added, and here we multiplied by a whole number. Now let's take another example. So what if we have, for example, 15, and then 13, and then 11, and then 9, and then 7, and then 5, for example, and so on, so on. So what we'll have here is a decrease. So we minus 3 every time. So minus 3, minus 3, minus 3, and so on. And here, what if we had, for example, 24, and then 12, and then 6, and then 3, and then, for example, 3 over 2, and 3 over 4, and then 3 over 6, and so on and so on. Here, what we do is divide each time by 2, which is the same as multiplying by half. So multiply by 1 over 2, multiply by 1 over 2, and so on and so on and so on. And let's give a name for this kind of difference here. Something that we add, this value, let's give it a name. With arithmetic sequences, what we have is something called a common difference, a common difference. So common difference. And we denote it with the letter D. And here we have a common ratio, not a difference, but a common ratio, and we denote it with the letter R. And now let's move on to getting some equations to describe both of these sequences. Now, first of all, I would like to denote some value with the letter A, and A basically is the value of some term. For example, if we have 1, and then 3, and then 5, and then 7, and so on and so on, we will have something called N and something called A. N states which place does a certain value take. So this is at N equal 1, this is at N equal 2, N equal to 3, N equal to 4. So this is N. But A, on the other hand, is the value of this kind of term itself. So if we will have A1 is equal to 1. This is A2, this is A3, this is A4. And it is important to know this because we will derive some formulas using these two kind of namings. So a recursive formula for an arithmetic sequence is as following. An is equal to an minus 1 plus d. And what this really means is that if we have some value and we add to it this d, this common difference, we will get the next value. For example, if we have 4 and then 7 and then 10, how will we get the fourth value, fifth value, and sixth value? The sixth value here. How will we get them? First of all, we will get a common difference. What is a common difference here? The common difference is, of course, from 4 to 7, that's plus 3. And here, plus 3. It's basically the later term minus the previous term. So it's the same as 10 minus 7 and 10, and not 10, but 7 minus 4, which is equal to 3 in this case. So this is the common difference, right? And to get this term, this term, this term, what will we do? So we know this is A1, A2, A3. This is going to be A4. Let's substitute A4 into the equation. Let's substitute A4 to the equation. What will you get? We will get A4 is equal to A4 minus 1 plus D. What is A4 minus 1? It's just A3 plus D. In this case, we know what A3 is and we know what D is, so we can get A4 simply. So A4 is equal to A3, which is 10 plus 3, which is equal to 13. So this is 13. And then the next one is, of course, 16 and then 19. We kind of, overcomplicated this, but this really describes how we identify arithmetic sequences based on the term that is behind them, how to get the later term using the term behind it. So we discussed for arithmetic sequences. What about geometric? So we'll have an is equal to an minus 1 times the common ratio r. So let's do it in an example here. So if we have 2, 4, and then 8, let's find the next 3 terms here. And this is, of course, A1, A2, A3. Let's find A4, and then A5, A6. So to do it and find A4, we will just substitute A4 into the equation. We will get A4 is equal to A4 minus 1 times R, and then it will be A4 is equal to A3 times R. But what is R exactly? It's actually the number that you use to get from this to this. We multiply by 2. We multiply by 2. And the really correct way to find it is dividing the later term by the previous term. So R is equal to 8 divided by 4, which is also equal to 4 divided by 2, which is equal to 2. So in place of this R, we will put 2. So let's erase it and put 2. And in place of A3, I will put this term here. This is A3. So let's do it. I will erase the whole thing and I will put 8 times 2 and it's equal to 16. So this is the term here. And then let's continue. We will get 32 and then 64. So this is a recursive formula. And again, what does a recursive formula mean? It basically means that you get the next term based on the term that is before it. This is a recursive formula. So again, this is the recursive formula. And this is also recursive, of course. Let's get into the explicit formula. Let's get to the explicit one. Explicit. And it is the one that we learned for arithmetic sequence. It's equal to, so an is equal to a1 plus n minus 1 times d, and the explicit for a geometric sequence is an is equal to a1 r to the power of n minus 1. So this is the explicit formula. And in this case, of course, you don't need to know the previous term to get the final term that you want. You only need to know the first term, the common difference, and the term that you want to find. You don't need to know the term that is before it. There is this important idea about means. And means come when we have some situation where we have an arithmetic or a geometrical sequence, but it misses some part of it, right? It starts and it ends, but the middle is gone. It does not exist. And to describe it more, I prefer to wait until the example problems, and there we will explain it further. We just need to use the equations that we learned and we discussed previously, and it's not very hard, and you are, inshallah, capable of doing it. Let's move to the idea of sums. And to talk about sums, we have to talk about this notation. This is a Greek letter which is called sigma, and it represents basically finding a sum of some certain quantity. Now, maybe a quick information for you to know. We have two letters in Greek alphabet that represent sigma. We have this and we have this. And the nice thing is in Greek alphabet, we also have two cases. We have the uppercase, capital, and then we have the lowercase. And both of them represent the same thing. So if you see this, it's also the same thing. Okay, so the sigma notation, it is really important. And let's take an example. For example, if we have the sum of 4n plus 4, for example, from n is equal to 1 to 4. There are a lot of 4s, but let's take this example. What this really means is we will substitute in place of n 1, and then 2, and then 3, and then 4, and we will find the sum of that. So just this. So 4 times 1 plus 4. This is the first thing. Plus 4 times 2 plus 4. This is the second thing. And then 4 times 3 plus 4. This is the third thing. And then 4 times 4 plus 4. This is the fourth thing. So what we'll get here, we'll get 8 plus 12 plus 16 plus 20. And this is going to be equal to 36 plus 12, that's 48, so 56. This is our answer. And you can always do it in the calculator, and just for you to know, you have to press Shift and then the logarithm button that is directly under the on button, and then you type the function that you have. So 4n plus 4, but I will write 4x plus 4, okay? Then from x equal to 1 to 4, and we'll get the same answer that we have here. To continue in the idea of sums, to actually find sums of sequences, we have some formulas for both arithmetic and geometrical sequences. So for arithmetic sequences, we have Sn is equal to n over 2 a1 plus an. We have another formula as well. Sn is equal to n over 2 a1 plus n minus 1 times d. This is the formula. For geometrical sequences, we have also two formulas, and they're quite easy as well. So we have Sn is equal to a1 1 minus r to the power of n divided by 1 minus r, and another formula is Sn is equal to a1 minus a n times r divided by 1 minus r. Both of these are formulas that can be used to find the sum of some sequence. A third formula is there for S to infinity. So if you find the sum of a geometrical sequence into infinity, this is going to be the formula. It's going to be A1 over 1 minus R, and it can only exist if we have R is less than 1. This is the only case where you can find a sum to infinity, only when it converges into some finite number. So to solve this question, we know it's an arithmetic sequence and we want to find the 12th term. So we want to find A12. And since it's an arithmetic sequence, then we know that it has a common difference, right? Not a common ratio. And we know the formula for it is an is equal to a1 plus n minus 1 times d. So we want to find d as well. So what is d? D is going to be the later minus the previous, right? So it's equal to 16 minus 9, which is equal to 23 minus 16, which is equal to 30 minus 23, which is equal after all to 7. And n is going to be 12 as well. So A12 is equal to A1, which is 9, plus basically the first term here, 12 minus 1 times d, which is 7. So it's equal to 9 plus 77, which is equal to 86. And this is our answer. So we want to find an indicated term with a1 is equal to negative 4, a common difference of 6, and a n is equal to 9. So since it's a common difference, we know it's going to be an arithmetic sequence. So we know we'll use this formula. an is equal to a1 plus n minus 1 d. And we have d, we have a1, and we have n, and we can find an. So a9 is equal to negative 4 plus 9 minus 1 times 6. So basically negative 4 plus 8 times 6, which is 48. And the final answer is 44, and this is the indicated term. In this case, we want to find A20 of a arithmetic sequence, an arithmetic sequence with A1 is equal to 15 and D is equal to negative 8. So A20 is going to be equal to A1 plus 20 minus 1 times D. Let's substitute what is A1 is and what D is. So we'll have A20 is equal to A1 equal 15 plus 20 minus 1 times negative 8. And if we solve this, we will get an answer which is negative 137. And now we go to this great idea of finding geometric means. So let's draw this. We want to find 3 geometric means between 2 and 1250. How do we do it? Let's draw the situation. So we have 2 in the beginning. So 2 here. Let me actually draw it without a line. So 2. And then we have 3 geometric means, right? And then we have 1250. What I recommend to do is to write the equation for a geometric sequence. So an is equal to a1 times r to the power of n minus 1. So this is an equation for the geometric sequence. We know what a1 is. We don't know what r is, but we know what n is. How do we find n? Here, n is equal to 1. Here, n is equal to 2. Here, 3. And then here, 4. And here, 5. And we don't know an, but we know a5, right? We know what a5 is. We know a5 is 1250. So let's write an equation using these kind of the information that we got. So 1250 is equal to a1, which is 2 times r. We don't know what r is. to the power of 5 minus 1. So just and to find r, because using r, we can multiply this value here by r. So multiply by r to get this, and then multiply and multiply and multiply to get the rest geometric means. So what r is? Using the calculator, of course, we can solve for r. So it's going to be, let's see, the answer is 5 using the calculator. R is equal to 5. And then we go to this sequence and we will multiply 2 by 5 and we will get 10. Then we will multiply by 5, not 50, but 5. And then we will get 50. And then we multiply by 5 and we will get, how much will we get? 250. And then if we multiply again, yes, we will get 1250. So this is the answer. So to find A1 in a geometric series where we have Sn, we have n, and we have r, I'll just remind you with the equation for Sn in a geometric sequence. It's equal to A1, 1 minus r to the power of n divided by 1 minus r. And let's just substitute the numbers. What is Sn? It's 13,116, and it's equal to A1, the thing that we don't know, times 1 minus what is r? 3. What is n? 7. And then 1 minus 3. And then we just, using the calculator, solve for A1. So let's see. I will put the values here. And we'll get an answer to be, let's see, 12. So A1 is equal to 12. This is it. So to find the sum of an infinite geometric series, I would like to remind you that the equation is S to infinity is equal to A1 divided by 1 minus r. Yep. And actually, I did not memorize this equation, but I understood it because it comes from this equation. Sn is equal to A1, 1 minus r to the power of n divided by 1 minus r. And what we know? We know that r is some fraction, right? It's smaller than 1. R is less than, not less than or equal, rather it's only less than 1. And we know n approaches infinity, right? And any number smaller than 1 that approaches infinity to the power of something close to infinity is almost 0, right? This is why we got this equation, and in future videos we will explain it further and we will prove this equation, inshallah. So let's substitute the numbers. So S infinity of what is A1? So let me rewrite this because it's not very clear. So we have 18 times 4 over 5 to the power of k minus 1 while k approaches infinity. So it looks just like the equation an is equal to a1 r to the power of n minus 1, where a1 is just 18. So S infinity is equal to 18 divided by 1 minus what is r? It's 4 over 5. So 4 over 5. And using the calculator, we can solve it. So 18 divided by 1 minus 4 over 5. And the answer is 90. And this is the answer. So it tells us here to write a recursive formula for this sort of sequence. And let me remind you, a recursive formula is a formula where we write how we get the next term based on the term before it. So what is happening here? Each time we're adding 8, right? So what will happen is to get an, we will take the term before it, right? An minus 1, the term before it, and we will add 8. We will add 8. Because again, the recursive formula for an arithmetic sequence is an is equal to an minus 1 plus d, while let me remind you, for a geometric sequence, it's equal to an is equal to an minus 1 times the common ratio. So I just substituted D. Now for the function iteration, it's just like a game, I think. It's really fun. So what do? You just take x0, and using this, you find x1, then you substitute x1 to find x2, and then you substitute x2 to get x3. So let's do it. So to get x1, okay, so basically I substituted x1 in place of f of x. So this is the first step. First step is you put x1 in place of f of x, and then you put 5x to 1 minus 1, which is x0, right, plus 4. So what will you get? 5 times 2 plus 4, and the answer is 14. And then the second step is you take this 14 and then you substitute it back here to get x2. So x2 is going to be equal to 5 times x2 minus 1 plus 4, which is the same as 5x1 plus 4. So 5 times 14 plus 4, which is quite a big number. So let's see what it is. It's equal to 74. And the third step to finish the game, x3 is equal to 5, you guessed it, x2 plus 4. So 5 times 74 plus 4. So let me write it here, 5 times 74 plus 4, which is equal to 374. So this is just iteration. We did not talk about it during the explanation, but it's a really easy concept. And this is it for this part. I hope you enjoyed it. And again, if you have any questions, feel free to contact at any time. Have a nice day, and thank you very much.